Okay. These are, shout out to Miss Daughtry. These are her notes, hence her little selfie right there. Say hi. Yeah, okay. If you click on those pictures or click on the spots where it says click here for the video example, it is her explaining it. So I think it works on your side if you're on the PDF version. I don't know if it works on the Notability version, but, oh, it does. Wonderful. So you can click those, watch those if you would like, but we're going to talk about them anyways, okay? So these formulas that you're given for sum or difference of cosine, sine, and tangent are what we're going to talk about today. So specifically on your gold sheet, that's going to be numbers 18 through 23, okay? That's what we're talking about today, 18 through 23. Next class, we're going to talk about 24 through 26, which means then you'll have everything on this gold sheet that you can use, okay? So today we're talking about 18 through 23. This first page is talking about cosine. Next page is talking about sine. Last page talks about tangent. So we're going to go one trig function at a time with these sum or difference formulas. But what I am not going to get into is the proof behind why this is what it is. Okay? If you really want to know why the cosine of a minus b is equal to this function here, go ahead, click on that link, look it up, Google it, that's fine. But what I care about in this class that you understand is what this formula is, which one I need to use, and how do I use it, okay? Does that make sense? Okay, wonderful. So the reason that these formulas exist is because we can figure out what the cosine of 15 degrees is, like the exact answer, without plugging it into a calculator, okay? Because right now, 15 is not on our unit circle, right? We could maybe guesstimate a little bit what it is, but it's not going to be very accurate, right? So what I can do is I can think about, okay, what are two angles that I could add or subtract that are going to give me 15 degrees, but that are on the unit circle? What are two angles that add together or subtract to give me 15? 45 and 30. I could do 45 and 60. I could do 150 and 135. There's a lot of differences of 15, right? So let's just go ahead. I like to usually use the first quadrant because there's less mistakes with negatives and things. So I'm going to rewrite cosine of 15 as cosine of 45 degrees minus 30 degrees. Okay, I know what the cosine of 45 is. I know what the cosine of 30 is. I also know what the sine of both of those things are because they're on my unit circle. And because I'm just so nice, your unit circle's on the sheet that you get to use on your quiz and your test. So as long as you remember that cosine is my what value, x, and sine is my y value, then we can evaluate these pretty easily, right? So we're going to use our formula, specifically the formula we're going to use for the subtraction. This is going to be using number 21 on your gold sheet, or the first formula up here. Okay, but I'm going to use that gold sheet there because that's what you're going to get to practice with on your test and quiz. So I'm going to do cosine of my a value, which is 45. So cosine of 45 times cosine of my b value plus sine of my a value times sine of my b value. Okay, last class they were asking me, well, don't you put the negative? No, that negative, this is the formula you're going to use for subtraction, okay? For cosine, it's always the opposite operation. You're going to use plus, but for sine, it's the same operation, okay? Okay, so now we can go ahead and just evaluate these things, okay? So cosine of 45 degrees, go to your unit circle. 45 degrees, that's my x value. So that means cosine of 45 degrees is square root of 2 over 2. Okay, cosine of 30 degrees, square root of 3 over 2. Sine of 45 degrees, square root of 2 over 2. And then sine of 30 degrees is 1/2. Okay, now we're just going to simplify this without making any silly algebra or order operations mistakes. If I multiply these two fractions together, I'm going to end up with the square root of 6 divided by what? You made that silly mistake. It's 4. Okay? And then we're going to add square root of 2 times 1 is the square root of 2 over 4. And now, if I add these two things together, square root of 6 plus the square root of 2, does that equal the square root of 8? No. So I'm just going to write it as the square root of 6 plus the square root of 2, and then divided by Don't say 8. What is it? 4. Okay, common denominators, you don't add those things together. Okay, so this right here is my answer. That is the exact value of cosine of 15 degrees, in case you were wondering, because I know you all were. You're welcome. Thanks, cosine formula, whoever came up with it back in the day. Okay, so we're going to do the same thing. We're using cosine still, but we have 5 pi over 12. Okay, so our brains don't really think very well. Well, most of our brains don't think very well with fractions. So what we're going to do instead is I'm going to rewrite just the first and second quadrant in terms of pi over 12s. Okay, so that way we know which angles we could add or subtract to give us 5 pi over 12. If you don't need to do that and you can just, kind of think what two things add together, that's great. But for everyone else, I'm going to write it out for us. Okay, so starting with pi over 6. So pi over 6, that would be the same thing as 2 pi over 12, right? Okay, pi over 4, that would be the same thing as 3 pi over 12. Pi over 3 would equal 4 pi over 12. Pi over 2, 6 pi over 12. 2 pi over 3. 8 pi over 12. 3 pi over 4. 9 pi over 12. And then 5 pi over 6 gives us 10 pi over 12. Do we agree with all those? Did I make any silly mistakes up there? Okay. The reason I wrote that all out once is because we'll use that again on the next page. So that way we don't have to rewrite it again. So we can copy paste. Nice thing about notability. Okay. So looking at all of these in terms of 12s, okay, what could I add or subtract to give me 5 pi over 12? I could add 2 pi and 3 pi, right? So I could do this one here and this one here. Is there another way that I could technically get 5 pi over 12? I could do the subtraction, right? I could do 8 pi over 12 minus 3 pi over 12. Since we already did a minus 1, let's just go ahead and try out the addition one instead, yeah? So we are going to do, this is going to equal cosine of, now I want you to write it in terms of what's on the unit circle, so I don't want you to write 2 pi over 12. I want you to write pi over 6 and the pi over 4. Okay. And now we're going to go ahead, we're going to use our formula for addition. So this is going to be using the formula number 20 on your gold sheet, with my A value being this pi over 6, my B value being pi over 4. So we are going to evaluate cosine of pi over 6 times cosine of pi over 4. And then I'm going to subtract sine of pi over 6 times sine of pi over 4. Okay, so now we gotta go ahead and simplify this stuff. So on the back side, cosine of pi over 6, go ahead and shout that out. What's cosine of pi over 6? Square root of 3 over 2. Cosine of pi over 4? Square root of 2 over 2. Minus sine of pi over 6. 1/2. And then square root of 2 over 2. Okay, let's multiply these things together. That gives me the square root of 6 over 4 minus the square root of 2 over 4. Which, when I combine that, does it become square root of 4? No, we keep it as the square root of 6 minus the square root of 2 over 4 for your final answer. Okay, this next example is going backwards. You're given the right-hand side of your sum or difference identity, and you're trying to figure out what the angle is actually going to equal, because I don't know what cosine of 87 or cosine of 93 is. But if I would either add those or subtract those, depending on which formula we're supposed to use, we can simplify that. So which formula am I going to use, number 20 or number 21 from your gold sheet, if this is a minus sign here? I'm going to use 20, right? So this is number 20 identity, where this is my A value, this is my B value, this is my A value, this is my B value. So if I evaluate this, this becomes cosine of 87 plus 93. We're just plugging it into the other side instead of the right-hand side. And what is 87 plus 93 equal? 180. And if I go to my unit circle, if you don't remember, cosine of 180 degrees is equal to -1. Again, this allows us, these formulas allow us to calculate stuff without a calculator if it is in, like, adding or subtracting of the unit circle. Yeah, okay. And then the other type of problem that you'll see in this section is it's going to give you, like, what is the cosine, tangent, or sine of 180 minus an angle or a different angle, might be on the unit circle, maybe 270, anything else. What is it going to simplify to? So all you're going to do is you're going to plug this into your formula. So since it's subtract, we're going to use number 21 on our gold sheet. And I'm just going to plug in 180 for A, and I'm going to plug in theta for B. Okay? So this becomes cosine of 180 times cosine of theta plus sine of 180 times sine of theta. And then we're going to simplify those unit circle pieces that we can. So cosine of 180, what's cosine of 180? -1. So I get -1 times cosine of theta. And then sine of 180 is 0. So I don't even need anything else. That's my answer. Negative cosine of theta. This one is all about sine sum or difference formulas, okay? Notice your formula is obviously going to be a little bit different this time because it's sine of angles added together or sine of angles subtracted from each other. So instead of them both being the same trig identity, it's sine and then cosine and sine. Sine and then cosine, then sine, okay? And then the other thing to notice is that if it's a plus for sine, it's the same, whereas cosine was opposite, okay? So we're going to do the same thing. We're going to plug in some values, or think about some values that if I add or subtract them together, I end up getting 75 degrees. So what two angles could I add or subtract to get 75 degrees?
Sine 30 plus sine 30, or sine 45.
Yeah, sine 30 plus sine of 45. Okay, no matter which order you're going to put those in, 45 or 30 first, you'll still end up getting the same answer. Your setup just might look a little bit different. So if I go and look at my formula sheet, we're using sine of A plus B. So this is number 18 that you're going to use. So I'm going to go ahead and give you a minute to evaluate. If you plug in those A's and those B values, this is A, this is B, go ahead and see what your sine of 75 is going to simplify to. All right, did we go ahead and get square root of 2 plus the square root of 6 over 4?
Yes.
Nice. Not too terrible. Just evaluating it might be the trickiest part if you don't remember which one's sine, which one's cosine. Okay. Maybe let's even write that as a little note. Cosine is your x value. Sine is your y value. And then we will do tangent on the next page. What's tangent if I was looking at my unit circle? Y over x. So from the previous page, these are all of our square roots, not square roots, but all of our fraction of 12s of our unit circle, okay? I would always recommend writing them in this way if you can't think in your brains what the denominator would look like, what the numerator would look like of your unit circle values, okay? So now we're trying to figure out how do I get sine of a negative 5 pi over 12. So like this whole thing is negative 5 pi over 12. So what two angles could I use to get negative 5 pi over 12? So let's go ahead and is a different one than I did with my first period, but it'll still give us the same answer. So let's do this. 4 pi over 12 minus 9 pi over 12, and that's going to equal negative 5 pi over 12, right? When I write out this piece, though, I want you to write it with the unit circle values. So that's sine of pi over 3, and then minus 3 pi over 4. Okay, so we're using our subtraction sign value, which means we're going to use our number 19 from our gold sheet. So I'm going to plug in my pi over 3 pi over 4 in for those a and b values. This is my a, this is my b. So I've got sine of pi over 3 times cosine of 3 pi over 4 minus cosine of pi over 3 times sine of 3 pi over 4. And then once you've done this, we just got to go ahead and evaluate what these things are. Sine of pi over 3, what's that going to give me?
1/2.
The y value. Square root of 3 over 2. Cosine of 3 pi over 4. Negative square root of 2 over 2. Remember, you're multiplying those, so keep that in mind. Cosine of pi over 3. That's my 1/2. And then sine of 3 pi over 3 pi over 4. Square root of 2 over 2. Evaluate this. This is going to give me negative square root of 6 over 4 minus the square root of 2 over 4, which I can write as one fraction, negative 6, square root of 6, minus the square root of 2, all over 4. Okay, now we're going the opposite way. We're given the stuff on the right-hand side. We're going to figure out what this equals, because it's going to be a value on our unit circle. So we look at this sign in the middle, and then I've got a sine and a cosine and a sine. So that either means I'm going to be either number 18 or number 19. Which one am I going to be there with that subtraction? Number 19, which means I am going to subtract those two angles. So I've got sine of 40 degrees minus 160 degrees. And if I subtract those, what do I get? Negative 120 degrees. So there's two ways you can think about this. If I have my unit circle, I could start here and go negative 120 degrees to figure out what that value is. Or you could use your number 12 property. And if you use your number 12 property, this makes it negative sine of 120 degrees, right? So then I could just figure out what is sine of 120 degrees and then just make it negative, right? So either way you want to do it is fine. But what is the sine value at 120? Square root of 3 over 2, which means this is negative square root of 3 over 2. I'm going to go ahead and skip example 6. It's just like on the previous page there, but with sine instead of cosine. So you would plug this into your formula and then just evaluate the sine of 30 and the cosine of 30s as you can. But I want to try out the tangent ones instead with you, okay? So any questions on sine or cosine, sum or difference formulas? Okay, moving on, last page then. Tangent of a sum or a difference formula looks a little bit more complex. I got like a fraction in there, and then it's either adding or subtracting on the top or the bottom, okay? So there's no cosines, there's no sines. So reminder, tangent of, actually I'm going to say theta, is equal to your y value over your x value, okay? Again, if you want to know how these identities came to be, go ahead. You're more than welcome to. There is a little proof there, or you can go ahead and Google tangent of a sum or difference proof, and it will give you a video of it too. But we're just going to go ahead and use these formulas to evaluate tangent of negative 15, tangent of pi over 12, okay? So let's see. Let's just do one of these. Which would you rather do, A or B? A? Okay, let's do A. We'll skip B, even though I think B we might struggle with a little bit more because it's the pi over 12. But that's okay. We'll do B. Or A, sorry. So how do I get negative 15 degrees with the angles that are on my unit circle? 30 minus 45, right? So it's the same thing as the tangent of 30 degrees minus 45 degrees. So if we are subtracting, we are going to be using number 23's identity. And we're just going to plug in our A value. We're going to plug in our B value. Now, again, just a reminder, you could have chosen a different angle. You could have done like 60 and 45, or actually backwards, 45 minus 60, right? It doesn't have to be 30 and 45, but I like first quadrant stuff anyway. So let's rewrite this as tangent of A, so tangent of 30 minus tangent of B, so tangent of 45, not negative 45, all divided by 1 plus tangent 30 times the tangent of 45. Okay, so I'm going to quick write out down here. Tangent of 45 is an easy one because if you look at 45, those values are the same for x and y, right? So tangent of 45 is equal to what? 1. Okay, that's easy to write down. I'll just say that's equal to 1. Now tangent of 30, it's been a minute, but if I take my y and I divide by my x, that means 1/2 divided by the square root of 3 over 2. I got a fraction divided by a fraction, so I can do keep, change, flip. This is going to be 1/2 times 2 over the square root of 3, which equals what? 1 over the square root of 3. Okay? You can rationalize it if you want, but you do not have to. Okay? So I'm just going to leave it as 1 over the square root of 3. Now I'm going to plug those two values in, and we're going to go ahead and simplify. Okay? So this becomes 1 over the square root of 3 minus 1, all divided by 1 plus 1 over the square root of 3, and technically times 1, right? By that tangent of 45. So now I've got fractions and fractions. That looks a little messy. Let's make it a little bit nicer. Okay, so I'm going to go ahead. I'm going to color code this here. I'm going to do the top in pink. And I'm going to go ahead and get common denominators and add those two things together. So what's my common denominator going to be? Square root of 3. So I'm going to multiply the 1 by the square root of 3 over the square root of 3. So in the numerator, this would give me 1 minus the square root of 3 over the square root of 3. Okay, then in the denominator, we're going to do the exact same thing. Common denominator here means I'm going to multiply the 1 times the square root of 3 over square root of 3. And this gives me the square root of 3 plus 1 over the square root of 3. And now we're close, but we still have fractions and fractions, so what can I do? Keep, change, flip. So I'm going to rewrite this as 1 minus the square root of 3 over the square root of 3. Then we're going to multiply by the reciprocal. And then what can I go ahead and cross out? What simplifies? The square root of 3 right there, right? Now, what I saw on the quiz was people do things like this. Can I cross those out? No, because why? There's an adding or a subtraction sign, right? I can only cross things out if there is a multiplication sign in between those two things, okay? So your final answer is actually just going to be 1 minus the square root of 3 over the square root of 3 plus 1. Now, you could technically rationalize that if you wanted to. You do not have to. I would just leave it like that. Make less mistakes. It's already kind of tricky to get there, right? All right, example 8 gives us the right-hand side of the equation. We're trying to find the left-hand side. So if I've got tangent of A plus tangent of B on the top, and then it's 1 minus tangent of A, tangent of B, am I going to use formula 22 or 23? Number 22. Okay, so 22 says on the left-hand side, I'm going to add those two things together. So this is going to be tangent of 80 plus 55. And 80 plus 55 gives me 135. So the tangent of 135 degrees. If you're not sure, flip that over, 135. Find your y over your x. And evaluate that to give me -1. All right, last example. What does tangent of 45 minus theta simplify to? So flip it over again. We're going to use number 23 because we're doing subtraction. And I'm just going to write it out and simplify what I can. So this is my A value of 45. My B value is just that theta symbol. So I got tangent of 45 minus tangent of theta, all divided by 1, plus tangent of 45, tangent of theta. Go ahead and simplify your answer. Final answer when you're simplified, this is 1 minus tangent of theta. And then, some of us forgot our algebra. If I had this, does that denominator become 2? No, not in this math world at least. It's just going to be a 1 down in the denominator there. 1 plus tangent of theta. That would be your answer right there.